Hello students, I'm Neeta Upadhyay and I'm going to teach you today work and energy with its part 3. Students, we have already discussed about work. So let us revise work again. Work is said to be done when force acts on an object and the object is displaced. Okay, these two things are important and it should be in the direction of force. The work done on an object is a product of the force applied and the displacement formula. Force into displacement, that is work is given by W, force F into S displacement. Now the unit of work is joule, students. Now this, when you see that W is equal to F into S, then if you want to find out the SI unit of work, then what you will do? Force Newton, S is displacement, that is meter, Newton meter. Okay, it is correct, student, it is Newton meter. But students, this Newton meter is also given a separate name. Okay, it is also given a separate name called joule. Okay, in honor of the British scientist James Prescott Joule. Okay, so joule is in fact the SI unit of work. If F is 1 Newton, students, if we consider F as 1 Newton and displacement as 1 meter, then the work done is 1 Newton meter, or you can say 1 joule. Okay, so how can we define 1 joule of work? If it is asked what is 1 joule of work, so 1 joule of work is the amount of work done. Okay, 1 joule of work is the amount of work done when a force of 1 Newton displaces an object by 1 meter. Okay, displaces the object by 1 meter. So force of 1 Newton displaces an object to by 1 meter. So it is called 1 joule of work, students. Okay, this in this way you will define 1 joule as you have defined 1 Newton. Okay, similarly 1 joule also you will define in this manner. So one example, student, if a force of 5 Newton acts on an object is displaced acts on an object and is displaced through 2 meter. So 5 Newton is the force and displacement is 2 meter in the direction of force. What is the work done? How can you calculate it? 5 Newton, F into S, formula F into S. So 5 Newton into 2 meter, that is 10 Newton meter also you can write, or you can simply write 10 joule. Okay. Work is a scalar quantity. This is a little bit, you think why work is a scalar quantity? According to the formula, it seems something different. So as we know that W is equal to F into S, okay, you can also write W, this formula in this way also. W is equal to F dot S, okay, or you can say that work done, okay, is the dot product of force and displacement. And we know that what is force? Force is a vector quantity and displacement is also a vector quantity. So we can also express it as work is expressed as the dot product of two vector quantities. These are the two vector quantities and it's a dot. Product means multiply. So it is a dot product of work is a dot product of two vector quantities, and students, the dot product of two vector quantities always gives a scalar quantity. Okay, this you have to remember that the dot product of two vector quantities will give a scalar quantity. This you will study in detail in the higher classes, and that is in the 11th class you will study in detail how it happens. Okay, so now at least for now you can remember that the dot product of two vector quantities always gives a scalar quantity. So work has only magnitude but not direction, which tells us that it is a scalar quantity. Now work done may be positive, negative or zero. That is sure. It can be positive, negative or zero. But this does not mean that it has a direction. Okay. Now students, we are going to study very important thing in this chapter. We shall be repeatedly dealing with the term energy. It is undoubtedly one of the most important physics concept. It is important because it represents a physical entity common to all forms of matter in all parts of the known physical world. In fact, you can say that life is impossible without energy. We use energy to do work. Why do we eat food, students? Okay? Why do we eat food? Normally from your lower classes you have heard. Why do we eat food? To get energy. Why do you need energy? To do work. That means if you don't have energy, you cannot do work. So we can say that energy is the ability to do work. How much energy you have, that much work you can do. Okay. In a car, the petrol is filled. Okay. To run a car, you need petrol or diesel. If the petrol, how much petrol is filled, how much diesel is filled, that much the car will run. So that much the object will do work, how much energy it has. So we can say that the ability to do work or cause a change is called energy. When we eat or bodies transform the food. Okay, when we eat, what happens? The bodies transform the food into energy to do work. Whenever we run or walk or do some physical work, we use energy. Similarly, I have already given example of cars, planes, trains, and various machines transform energy into work. Okay, energy lights our cities, moves our vehicles, runs the wheels of the industry. It also warms and cools our homes, places of work, cooks our food, plays our music, entertain us through television. Where do we get all this energy from? In fact, most of our energy needs are met by sun. That is the main source of energy, students. What we are studying from our lower classes and what we know that the main source of energy is the sun. We also derive energy from earth also, like geothermal energy it is called. From wind also we take energy, that is wind energy. From tides in the ocean, that is ocean energy. And the from water also we take energy, that is hydro energy. From biomass, okay, from nuclei of atoms, that is nuclear energy. So there are many forms of energy. Scientific conception of energy. Okay, when we say that a man or a horse does work, how did they do work? When they pull a load. Okay, if they pull a load, we can say that a man or a horse does the work. A moving body can set other bodies in motion, isn't it? If a body is moving, it can set the other body also in motion when it collides with them. Okay, all these simple examples we have already discussed in many of the examples, many of the topics which we have covered in physics. So so energy is basically what? It is the ability to do work and cause a change. Okay, how does an object possesses energy to perform work? Okay, the thing is that how does if imagine object A is there and that is possessing energy. Okay, and that object can exert force on another object B and transfers its energy to B. As a result of this, the object B may move and do some work. Like if you're standing, you have energy in yourself, the energy is stored in your body, and a ball is kept on the ground. And imagine that object A is you are the object A, and the ball is object B. Now you have energy in yourself as chemical energy. Now you hit the ball. Now that the ball is hit, the energy from your body is transferred to the ball, that is the object B. As a result of this, the object B may move. As a result, the object B, that is ball, may move and do some work. Thus, the object A, which made the object B to move and perform some work, had the capacity to do work. Thus, any object that possesses energy is capable of doing work. Okay, so here we are going to study in detail about energy. Now, the energy of object is a capacity to do work, and unit of energy is same as that of work, students. That is joule, because they are same. How much energy you have, that much work you can do. So here the unit of energy is also joule, students. So how can you define 1 joule of energy? 1 joule is the energy required to do 1 joule of work. Okay, simple. Like if thousand joule makes 1 kilojoule, that is 1 kilojoule is equal to 1,000 joules. Okay, there are different forms of energy, students, like which have I already, while explanation I have told you many types of energies: heat energy, light, and these are all forms, many types of energy, you know, students. Basically in this chapter we are going to study about the mechanical energy, that is a potential and kinetic energy. Let us discuss this different forms of energy, students. Mechanical, we are going to study in this chapter kinetic and potential energy only. And we should also know about we have you should know about thermal energy, also nuclear energy, and you have heard also about them: sonic energy, gravitational, kinetic, potential, ionization, electromagnetic energy. Let us just see more about them, understand more about them. Like forms of energy, student, when we talk about mechanical energy, we are talking about the objects moving, like the moving car, leaping frog. Okay, machines. Thermal energy, student, for heating soup. For heating soup, what we are doing, we are using thermal energy. Melting of ice cream is a thermal that energy. Electromagnetic energy is present in the radio waves, infrared radiations, visible lights. And you can see electrical energy, power lines, lightning, natural, in the nature you can see lightning, that is electrical energy. Then chemical, students, the food we eat is a chemical energy. They contain carbohydrates, proteins, and when we eat, then we perform work. And student, plants also, the they undergo photosynthesis to prepare their food, that is a chemical energy. Okay, they okay, glucose is produced, and energy, sorry, when we eat food, we our food is broken down into glucose and energy, that is also chemical. In plants, photosynthesis. Okay, uh, then striking a matchbox is a chemical energy. So the nuclear energy, nuclear fission inside the earth core. Okay, nuclear energy is also seen nuclear fusion. Two types: nuclear fission is there and nuclear fusion is there, which is seen and sun and the stars. Okay, more examples if you want to know, student. Mechanical energy, lawn. Simple examples in our everyday life, we use all these types of energies, like the lawn mower in the lawns to cut grasses, that is a mechanical. Bicycle is a mechanical energy. Gears, scissors, hammer, these are the small machines in which mechanical energy is used. Electrical energy, students, the electrical irons, then the blenders, pencil sharpeners, electrical. Students, this blenders, computers, curling icon, this irons, no, curly irons, the females, girls and men also sometimes use to curl their hairs. Televisions. Examples of light energy: flashlights, traffic lights, lasers, lamps, light bulbs. Example of thermal energy, very simple examples: fireplace, students. Sunlight is a main source of thermal energy. Campfires, old time stone they used in the old time to produce heat. Then stove, students. Then examples of sound energy: headphones. Shouting is when you're shouting you're producing sound energy. Drum, guitar, speakers, all these are the different types of energies and their examples which we see around and we use them. Okay, so thank you, students, and you will study more about energy. Like you are going to study in this chapter in ninth, kinetic and potential energy. And so, thank you and take care. I will be back with about energy. I will be back with about potential and kinetic energy. You will understand more about potential and kinetic energy and law of conservation of energy. Thank you, students, and take care.